So finding similar triangles. The original diagram included a smaller triangle inside a larger triangle. So we must redraw them as separate triangles. So the way I would do this is redraw them. Okay, when we redraw them, let me just add 3m here and 6m here, because 3 plus 3m, right? You're drawing the whole thing, so that's got to be 6m, and that's 8m. Okay, so if you're looking at this, and these are both right triangles, I already know, and one is within the other. Okay, so LKJ is similar to triangle MKN. So triangle LKJ is similar to triangle MKN because all the three pairs of the corresponding angles are congruent. So we know that one pair of the corresponding side lengths is NK and JK, and together they form the fraction NK over JK. So if you write this down, NK over JK. All right. And another pair of side lengths is MN and LJ. And together they form a fraction MN over LJ. Okay. If you look at that. And together, in both fractions, the numerator comes from triangle MKN, and the denominator comes from the triangle LKJ. Since the triangles are similar, you can use fractions to set up a proportion and solve for u. So let's do that. Okay, so we know that. So MK JK is equal to MN LJ. So NK JK is equal to MN LJ. Okay? And you want to plug in the side lengths. So I would do 6 over 3, right, is equal to 8 over u. So we don't know what u is, so we got to figure that out. Okay? So, very simple. I would cross multiply here. Okay? 6u equals 8 times 3. Okay? So 8 times 3 is 24. So divide both sides by 6. So u equals 4, because 6 times 4 equals 24. Okay? So the missing side is 4 meters long. Okay? In length. Okay? Another example is something like this. So in the diagram below, a triangle HIJ is similar to triangle HKL. So we need to find B. Okay? And the best way is to, again, separate the two triangles. And let's do that. Okay? So triangle, this is a lot easier to see. Triangle, okay? Triangle KHL, KHL, and triangle, if you flip it, I would flip it this way, triangle, here, let me just do that better, okay, triangle, JIH. Okay, and that means that if we look at them, this is 5 and this is 5, this is 5 meters and this is 5 meters, and one of these sides is 10 meters. Okay, HL, sorry, HL is 10 meters. Okay, Okay, so what does this mean? It says find B. Okay, oops, sorry, find B. B is right here. KL is B. We're looking for KL. We're looking for this here. Okay, so what does that mean? Okay, it means that triangle HIJ is similar to HKL, which means that triangle HIJ is similar to HKL, which is we have one pair of corresponding side lengths, which is JH, JH, and LH. And LH are corresponding sides. Okay, and together they form a fraction JH over LH. Similar, another pair of corresponding sides is IJ and KL. IJ and KL. And that forms another fraction, IJ over KL. Okay, like here, okay, let's look at this over again. Okay, JH, and I'm going to use blue. No, green. I want to use green. Okay, JH. JH is the same as, okay, LH. And IJ is KL. Okay, and if we look at it, and we're going to continue on from here, okay, in both fractions, the numerator comes from HIJ, and the denominator comes from HKL. Since the triangles are similar, you can use a fraction to set up a portion and solve for B. Okay, JH over LH is equal to IJ over KL. Okay, so very simple, just plug in the numbers. Okay, which is going to be 5 over 10 is going to equal to 5 over B. Okay, cross multiply, you get 5B, right? Cross multiply, 5B equals 50. Divide both sides by 5. You get B equals 10, right? 5 times 10 equals 50. Okay, and the missing side length is going to be 10 meters in length. Okay.